Today we're going to continue on with the next engine in our series. We just finished the ISX 871 and we're going to talk about the ISX 2250 and 2350. The big changes in this engine was the 871 did not use DEF fluid. It didn't have an SCR system. This engine does have an SCR system that is in addition to the diesel particulate filter system. The 2250 and the 2350, to the untrained eye, they look identical. There are some subtle differences. The main difference between the engines is the ECM. On the 2250, the ECM didn't have the power, the hardware power, to control the after-treatment SCR system. But the 2350 ECM, they built that hardware in and changed the software so that it could. So in the 2250, when we take a look at the picture of the engine, I'll show you an extra controller that's bolted up by the depth tank or up in the frame. And that controls all the functions on the aftertreatment. We'll talk about that in depth in another video. So let's take a look at the differences between the 871 and the 2350 series, which is significant differences. And here we are, a picture of a 2250 in chassis. The differences between this engine and the 871, even though they're ISXs, the differences are just huge. So let's start with castings. You've got a completely different cylinder head. Instead of two cams, you've only got one cam. Because the injectors are now fired by the ECM electronically, you no longer have an injector cam. As you can see, the EGR pipe number 5 comes over the top of the valve cover. On the 871, it went around behind the engine. The 871 had a cold side EGR, so does this engine, but they put the EGR valve and the EGR cooler on top of one another. You'll see that on the other side of the engine. Let's go down to the ECM. We'll start with that, number 1 on the bottom right. The ECM has two 96-pin plugs. There's no 4-pin power plug anymore. The ECM's a lot more powerful. It controls the aftertreatment through an aftertreatment controller through a basically just data bus harness. So you'll see in another photo a plug I'll show you that plugs into really an extension cord, if you will, that takes it to the back of the truck to the other computer, which I'll show you at the end of this video. So there's kind of two ECMs on this. One runs the engine, and there's a little secondary ECM that controls a lot of after-treatment functions. Let's go to number 2. It's got the common rail fuel system. That's your common rail. We'll see this better in another photo, so I'll go through this one fast. Number 3, each injector has its own connector and is fed fuel individually through a steel line. Number 4, there's a fuel pressure dump on the common rail so that if something fails in a pump, we don't have lines fracturing from pressure. Number 5, our EGR flows over the top instead of around the back. Number 6, we've got insulated crankcase filter. That's the tube off of the crankcase filter that takes the air to the atmosphere. That's now insulated to help it from stop it from freezing shut. Number 7 is a pressurized fuel filter. The pressure in there is about 185 psi. Number 8 is your crankcase filter, and this is a heated cover. You'll see in another picture the power cord coming to it, but now we've got heated crankcase covers so that the ECM can defrost those if it's cold enough, run heat to them. Number 9, in the back on the top left there, we're now pulling the crankcase air right out of the top of the valve cover. They punched a hole in the top of the valve cover, and we're taking it out of there instead of the gear housing cover in the front. So let's move on to our next photo. And here's a picture of the engine out of chassis. You can see it a little better. And let's go to number 1 on the bottom left. And we've got a common rail pump now. Remember on the 871 we just had a gear pump that made about 320 pounds of pressure. On this we've got a common rail pump that makes very low volume but very high pressure, and this can make up to about 32,000. It's regulated right about there. We go over to number 2, which is your electric lift pump. It looks different. It's almost like the mid-range ISC pump. It's down on the bottom. You'll see this in my fuel system troubleshooting videos. Number 3, your inlet is down by the pan rail instead of up on the side of the engine because there's no IFSM. And that housing's got a check valve in it, and the fuel goes into the fitting there by number 3. Number 4 is the gear pump, and this pump only makes about 135 to 185 psi, which you have running down the road all day. And number 5 is the common rail. And then number 6 is the oil pressure sensor and the oil temperature sensor. They're right next to each other. It's not a combination sensor anymore. Number 7 is your OEM ECM plug. Number 8 is your engine ECM plug. Number 9 is the connector that would go back to the after treatment. Before I said it was sort of like an extension cord. That's a connector. I think it's a 8 or 10 pin connector, but they only use about 4 pins in it. Number 10 is the fuel filter. Again, it's pressurized to about 135 to 185 psi. Number 11 is our valve cover. It's changed. It's got a different kind of gasket on it. The gasket is a hard one-piece gasket. And these are the covers. If you hose them off a lot, you can see that those fiberglass bosses will hold water around the bolts. Number 12 is your data port right there. Number 13 is your fuel actuator that controls fuel pressure in the rail. 14 is your air compressor inlet from the intake manifold. 15 is the cylinder head, which has only got 1 cam in it. And number 16 is where they take the air in out of the valve cover that goes to your filter for the crankcase. Here's the front of the engine. Number 1 is a different cover. There's only one cam gear back there. You've got a plug at number 8 so you can get a feeler gauge down there if you have the gear train loose up on top, so you can set it. Number 2 is your crankcase filter piping coming out of the valve cover and going into number 4, the crankcase filter. Also right there at number 4 is the crankcase pressure sensor. Number 3 down on the bottom, they've moved your crank pickup sensor from the gear housing into a plate in the front of the gear housing versus the side of the gear housing. Number 5, you've got heated covers on the crankcase filter so they don't freeze. 6, you've got the over-the-top EGR valve pipe. And number 7, you've got a completely different valve cover. If you look over at number 1, up on the top left of it, you'll see the camshaft sensor. They moved that from the side of the head over the top front of the aluminum gear housing. Okay, let's take a look at the back of the block. Number 1 is your fuel control valve that sends fuel over to the valve on the turbo on the right, number 6. And that is an injector number 6 is an injector that injects fuel back to heat the after treatment. Number 2, right above number 1, is an air valve. That's an addition on the 2250. The 871 didn't have it. That air valve receives its air from the air tank on the truck, so it's got 120 psi going into it. And when the engine is done injecting fuel for the after treatment, that air valve is turned on, and it basically blows all the fuel out of line number 4 going across the back of the engine to that number 6 and blows all the fuel out of number 6 so that it doesn't carbon up as much. Number 7 in the center and the bottom is flywheel housing. As in all the ISX engines, there's a cast hollow in the back of the flywheel housing, and that is the rear oil rifle. So oil comes out of one side of the block, goes into the flywheel housing, and goes across the other. It's not a tube in the flywheel housing, it's just when you take it off, it looks like someone hogged out a big groove across it. You've got a steel gasket with a rubber seal in the back that seals all of that. Up on the head, number 5, you've only got one cam thrust plate in the back because the injector cam is gone. Because on a common rail, we're firing injectors with the ECM now. Number 3 is your EGR pipe. Instead of going across the back, the EGR valve is up on the side. We'll look at that coming up next. Here we are looking at the passenger side of the engine, or turbo side. A lot of changes here. Number 1, it still has an EGR cooler, but the EGR cooler is constantly being redesigned, and they've got it today to where it's pretty stout and really not a problem anymore. Right behind number 1 to the left of it is the EGR flow cooled gas out. It comes up at a 45-degree angle, and then up at the top of the engine, number 2 is the EGR valve motor. And number 3 is the EGR throttle plate tube. And if you look in there, it actually is a throttle plate like you'd see in an old carburetor or a butterfly valve, whatever you want to call it. And from there, the gas goes forward into the EGR sensing housing. And that's about a 10-inch long housing that bolts on with 2 clamps with O-rings. And that is housing number 4. They water cool that housing. That's number 8, the water lines, because it does have hotter gases going through it and they want to stop carboning. Number 5 is an exhaust gas pressure sensor. It's called an orifice sensor. It's the same part number sensor as you have in the exhaust gas pressure sensor position up by the thermostat housing. Number 6 is your EGR differential pressure sensor. Again, this housing has ports that'll plug up. There's small Allen plugs underneath that steel plate that you see facing you underneath 5 and 6. If you take that off, you can take those little ports out and clean the carbon out of the holes. Number 7 is your EGR temperature sensor, and that measures the temperature of the air, EGR air going up back into the engine, because that's very important. We've got a new addition, number 9, on the cast iron housing behind the turbine outlet. And number 9 is your NOx sensor, which senses nitric oxide. And this is called the inlet NOx sensor. And that's because it's the inlet to the aftertreatment system. We're done with the engine, we're going into the aftertreatment. So number 9 is your inlet NOx sensor. Okay, let's get to the aftertreatment controller. So you remember that I told you that on this engine they added SCR. The ECM on the engine wasn't powerful enough to take care of all the new functions with the common rail and the additional sensors. So they had to have a secondary ECM on the unit, and that's what this little box is. And as you can see, there's quite a few pins in it. And this box communicates with the engine's ECM over a data bus, 2 wires, and this box is in charge of controlling. It's really kind of a giant relay box that the software talks back and forth from it, because it does have firmware in it. The firmware talks to the engine software, tells it what's going on, and the engine software gives it commands, and then the firmware executes those commands through the transistors that are inside the box. And this box is in control of looking at the temp sensors in the SCR and the DPF restriction sensor, the NOx sensor that's on the SCR brick. If there's an NH3 sensor, it takes a look at that, and it takes all those functions, and it's in control of the DEF pump and the DEF heater lines. and the DEF injector. So all those functions are controlled by this unit, and then it communicates back and forth to the engine ECM. And that is the heart of the system on the ISX CM2250. Now to finish this video off, the 2250 and the 22350 platforms are very, very similar. Again, to look at the engines, you'd never know there's any difference. But what they did do is on the 2350, which that came out in 2013. Remember, the 2250 was born in 2010. So 2013, we went from the 2250 to the 2350. And in the 2350, we moved that after-treatment controller you just saw to inside the engine ECM. So now the engine's ECM controls everything on the unit. And it has a harness that goes to the back. It's got a few more wires in it. And the modules in the back have smart modules on the temperature sensors and the knock sensors. So all that is ganged together and is still controlling everything through a data bus. Thanks for joining me on Neural Splendor. See you next time.